Time to play the game!
Hello again. In this video, I'm going to tell you about pointer arithmetics. I hope you're focused, because this is usually the moment where people drop out. You'll see, it's quite simple really, but for some mysterious reason, people usually struggle with these notions. Let's do this. Here's the main I've prepared. I've declared a and b, both integers. I've assigned values to those variables. And then I'm using self-made functions to display the address of a. And then display its value. And the same for b. Address, then value. Let's see what happens. See, we have the address of a and b. Notice how similar those addresses are. A is actually 4 bytes further from b. That's normal. I told you about the stack earlier, and when you declare objects on the stack is actually all the way at the top of the addresses. So when you declare something on the stack, you go through addresses downwards. The difference between a and b is 4 because an integer is 4 bytes. So here you go. The address from a is 4 bytes away from the address of b. Let's create a pointer star ptr. And ptr equals ampersand b, the address of b. Yes, I've selected b's address. As I told you, b is after a on the stack, but the address comes first. That's just how it is. If I wanted to do the exact same thing here, I'd have to write this. That used to be a's address, ampersand a, ptr being the address of b. You'd think we could write ptr plus 4 as b is 4 bytes away from a, but our compiler is smarter than that. It knows ptr is a pointer to an integer. So when you type ptr plus a value, it multiplies this value by the size of an integer. It's logical for you to move it integer by integer. So to go from b to a, I'd have to type ptr plus 1. Now, here I use the display value of a. To display the value of the pointed object, we used an asterisk. So star ptr should display the value of b. But now I can do ptr plus 1. Normally, I should be allowed to do this. So what does that mean? It means I'm taking the address contained within ptr, I'm going to do plus 1. The compiler knows it's a pointer to integer, so it's going to add 4 bytes. And this asterisk means check out what's at this new address. Logically, I should display the address of a and its value 3. Even though I'm using ptr, which points to b. Recompiling, relaunching. Here you go. If you compare this to our previous result, I've displayed the address of a. Wait, there's a slight difference. That's odd. Oh yeah, that's because I recompiled and relaunched the program. So it doesn't have the exact same address. But that's okay. What's important is that I'm indeed displaying a's address, even though I used b's address. Because addresses can change every time you relaunch a program. But that's another story. Now that we've done this, I want to show you that it's different with characters. So imagine I change my integer here and replace it with a character. So char a, character b, and instead of ptr pointing to an integer, I'm going to make it point to a character. I need to change this because I can't use 3 anymore as it requires characters. So I'm going to use the ASCII character 3 for a just to mess with you. I'm going to use the ASCII character O for b. And here I'm going to replace ft underscore put and br by ft underscore put char because we'll be displaying characters. So here, normally you have an a with the ASCII 3, b with the ASCII value of O, ptr that points to b, ptr plus 1 which should be the address of b plus 1. Yes, a character is 1 byte. So when you move from character to character, we move byte by byte. Just to show you, I'm going to add extra lines. I'm taking the address of b, I'm going to display the address of b, and then I'll display the rest. Recompiling and relaunching. As you can see, ptr plus 1 byte because we're using characters. And we can do this with any type of variable. And every time you do, the computer knows the variable size you're pointing to. So it'll be able to move accordingly. Last detail, just for laughs. Let's use integers again. I'm going to change the value of A to 1, the value of B to 42. We'll keep that display as the address of B. And change PTR plus 1 into PTR plus A. You can call a pointer with an integer. It's the same as 1 being a static variable. Let's check out the output. The address of B is displayed. Same for the address of A. And I forgot to display something. I forgot to change my ft_put character. See, I've displayed 1, which is the value of A from PTR, which pointed to B. We've covered pointer arithmetics. See, it wasn't that complicated, was it? Just remember that what you can do calculations with an address, and then use an asterisk to check what's at this address.